Welcome back. I just had a quite frustrating experience. I set everything up to actually make the PCB for the controller, and yeah, after I set up the table saw with the diamond blade and adjusted everything, I noticed I don't have a fitting piece of PCB material. So in this day and age, that means I have to wait a few days. I cannot go to the city and just to my electronics store and buy it. No, I have to wait a few days until it arrives by mail. So instead, in this second part of the laboratory shaker, I will continue with the mechanical stuff. So I have here some raw material of 4 plates of polycarbonate, 8 millimeter thick, and incidentally, yeah, polycarbonate, the same material I made the laboratory water bath of, but there I used 10 millimeters, so I'm feeling lucky, going down by 2 millimeters, and yeah, a card to that project here. And yeah, of course, we saw that in the overview, in the intro, I have my plans. And in addition to that, I have a plan for, yeah, at least the first set of cutting operations I have to do to get actually out of these 4 raw plates 10 parts, which I have to glue together in the end. And yes, I said gluing. Obviously, I'm feeling lucky. Anyway, there are a lot of cutting operations here. It only says 1 to 6, but you see there are 3A and 3B, 6A and 6B, and some cutting operations are, yeah, twice. Cut C to twice 200 by 45, and so on. So let's get started. Now I have the raw parts for my fixed bottom half and my seesawing top half. Let's see if everything really fits together. Okay, the pieces of the bottom half fit almost perfectly together. Just these smaller side pieces, they seem to be, I don't know, less than a millimeter too long. So yeah, I have here something standing over, and yeah, here at the other side also. I have also the feeling that at least one of them, but that's just a feeling, I have to test that, is, yeah, it's not quite a right angle here for some reason. I mean, minuscule differences, but still I want to glue that together so it should fit. And but the big pieces here, the big side pieces, they fit perfectly, so no troubles here, which is a good thing because I have to do some more operations on these two. Yeah, same for the top piece. Eerily, that side here seems to be fitting just perfectly. Yeah, there is no wiggle, or yeah, maybe a little bit. It's a little bit too long. Maybe, yeah, 0.2 of a millimeter. But the other side piece here, that's yeah, that's also, yes, there shouldn't be some no wiggle. So yeah, like by the bottom part, the side pieces are a wee bit too long. Upon a little closer inspection, I discovered that the problem is a little bit deeper rooted. In fact, that edge here is about-ish 221 millimeters, and that edge here is only 220.5 millimeters. So, yeah, and if you watched the cutting carefully, that was the very first cut. I started it with the blade very low, and then I got into trouble, and so I restarted the cut after adjusting the blade a little bit higher, and then I went through. So yeah, I f***ed that up. I see some sanding in my future. So that's the best rig for sanding a right angle, a 90-degree angle I could come up with. So yeah. To the best of my knowledge, this is really all 90 degrees, and it's of course clamped to my desk, and to give it even more stiffness, I used an old piece of a kitchen countertop, very thick. You can see it maybe here in the edge. Yeah, and this is also very, very flat. And I can move this piece here, of course, with some sandpaper on it, and yeah, then we start filing that down. Maybe I use another piece, huh? This is a little bit awkward. But the important thing here is I can fit this here in, no problem. Yeah, that's the edge too short, and I can't fit it in here. Okay, let's get sanding. Okay, that was tedious in so many ways. First, I only had 120 grit sandpaper, which was much too fine to take off a good amount of material. Second, this is plastic, so it gums up the sandpaper quite fast. Next point, did I mention polycarbonate is really, really hard. It's a really hard plastic. Okay, but yeah, I think it's good enough. I mean, you can imagine that there is still, it's not quite perfect, but yeah, it's perfect enough. And yeah, this thin piece of metal sheet, it's 0.3 millimeters, and yeah, I can't. Maybe here at the edges, I can't fit it in here, press it in here. Okay, another problem I ran into. At the beginning, I just fixed here the sandpaper with 2 pins, and then it was making waves here when I made a stroke in that direction. It waved, and so it started to drool down that edge here. But yeah, I corrected that with simply putting in more pins. The edges, if you look very closely, you can imagine that they are still a little bit drooling, but that's okay. So yeah, next steps, getting these to size here. Now, that was much easier, partly because this is a smaller surface you have to sand. Second, I had 80 grit sandpaper that, yeah, was long enough for these parts, and it didn't gum up. You could simply, yeah, brush that stuff off again. you can clean it and reuse it. So that was good, and now everything is fitting together perfectly. At the bottom half, we only had one single problem. These side pieces here, they are a smidgen too long, so you have, when you feel here at the side, you have a step. But these are even smaller, so this should be even easier. And you noticed I mark the pieces, how they fit together. That's it, filing done, and yeah, I just noticed that the desk was always, wandering out of the picture. Sorry about that. Anyway, it's time for some drilling now. I marked on one of the bottom side pieces where the axle will go through. And I also marked how they will be mounted on the base plate. So first I will put them together with that as a reference edge and the bottom as a reference edge, and just, attach them firmly to each other. So I can be sure they are, the hole is going straight through. And now comes the drilling, the usual. Sorry for the noise. Center drill and a bit larger drill, even larger drill, and then enlarging the whole thing by hand. Same game with the, upper side pieces. Really nothing new. Just for the fact that we have to drill two holes, one for the main axle and the other for the axle where the push rod of the servo will be attached. Side note, I had to move, that clamp here to get to that hole, and I used a drill through the already drilled hole as an index, together with that one, so everything stood in place. I need two more holes here for M3 grub screws to hold the axle in place when it goes here through the upper side parts. I had to profile the holes here a little bit because my M3 tabs won't reach all the way down. So I widened it here at the top so the the shaft of the tab would fit in here. Okay, let's cut some threads here for the grub screws. These were the M3 tabs, for the grub screws, here for the axle, and then, for the pin that is going here through for the push rod. And I just noticed, I just, drilled these two holes just to 6mm, but my axle is 8mm. So, I won't film that, so that you know. I have some more cuts to make, especially in the bottom part, side pieces. Remember, the axis is going through here and the top is supposed to seesawing around this axis. So I need cutouts here to give it actually space to seesaw. And yeah, for the long edge, I just took here the other side pieces of the bottom, which will go here as a template. And yeah, the rest I will wing. And I will have to obviously flip that around for the second cut. And I won't do the cuts completely to where the two lines join, because otherwise I would undercut it with the saw blade. So I stop about here at the red markers 6 millimeters before the end, and the rest I will do by hand. Okay, that was some sawing and filing too, but I have one question for you. Why did I put all these bright red markers on here and then undercut at one edge anyway? Last two cutting operations, hopefully. I mean, my axle is a little bit too long, so I need, of course, a 200 millimeter piece. And I also need, for some other stuff, a 40 millimeter piece. The axle should not be hardened. See the mailbag here in the card and link in the description. You can scratch it with a file. So I think I can cut through it with my HSS blade here. However, that blade is a little bit small, so I might have to do 2 or 3 passes to get really through that stuff. Let's do it. And of course I'm using cutting oil. Okay, there's no way in hell I can cut this with this saw blade. It's harder than I expected. So I need some other measures here. But I was able to scratch it, especially here at that end. I have a nice start for whatever I will do next. Next is obviously the big iron saw. Again, some filing involved, but this is my stub. We will see that later. And that's my axle, which came out to exactly 199 millimeters, which is okay. So it doesn't stand out at the sides. So the sides will be smooth, and I think it's time to clean the bench. No. Not just yet. I have to do some experimental milling of radii. Okay, this is borderline crazy. So I have here with 2 clamps my vise, and the vise is holding that short piece of axle, and that side piece can pivot around it. And here in my drill stand, I have a milling bit. So if I turn that 180 degrees, I should have a nice radius here. Or everything flies apart into my face. We'll see. So that's the result of my first attempt, and admittedly it looks a little bit crappy, but anyway, that's the part where I undercut here anyway, so this will go into the back of the unit where I will never have to see it. The second attempt, not too bad. Yeah, you notice the radii are not quite complete. The reason being for, yeah, some reason, this is not 40 millimeters. This is 38 point something, 38.8 millimeters. So I cut that too narrow. I have no idea why. I mean, I have an idea, but okay. It's not really critical dimension. So yeah, one more operation and I think we're done. Oh yeah, one more thing. The first attempt looked so atrocious because everything moved here, because the clamps I was using, they were not strong enough. When you're milling, of course, you have very high forces. And yeah, I tried to go very slow, but it was too much for these clamps. So for the second attempt, I took real steel clamps here and yeah, this is not moving anywhere. So it looked much better. Last operation, I need a little dimple here in the material to let the servo cable through. And yeah, more filing. Okay, that's it. I guess I will clean up the whole mess now here and then we can do some test fitting. Test fitting. I'll start upside down with the top part at the bottom because it's the bigger part, and then I'll try to get the axle through all four holes and yeah, put the bottom plate on top and see if everything's moving like expected. And I will also, yeah, accelerate the process in video. Okay, maybe you can see that, maybe not. Let me zoom in here. But yeah, the axle is zoom. The axle is here coming a few millimeters off, and that's, I mean, you can force it, but yeah. I have to work on that a little bit more, and I will do that by scraping this hole here a little until I can easily, yeah, push the axle through. I scraped that hole just with an 8 millimeter drill, you know, putting it in there and yeah, moving it back and forth, applying force a little bit here off axis. So yeah, the axle is now going here in smoothly. And yeah, I'm avoid touching the axle here because afterwards, if everything is glued together, I can't touch the axle. It's inside. I can, yeah, touch the upper or lower part, but now I can, yeah, push in the axle without any problem. So next question is, will the the lower part, which is up now, also fit? Yep, I mean, you can't see it, but I can feel it. No problems at all, and it's Seesawing. Wonderful. So, next step, cleaning again everything and gluing it all together. Here we are again at the right angle. I went with sandpaper over all edges and corners. I vacuumed the parts and then cleaned them with alcohol. Yeah, there's a little bit of shimming here to get everything absolutely perfect. Oh yeah, perfectly enough. And now we will glue these two parts, side parts, to the top part. And that's it for now. The stuff is light curing, obviously. I don't have light here, a direct sunlight. I opened the window. I have to because obviously that stuff, acrylics, is quite poisonous. It was also in a mailbag. Maybe I already linked it, carded it. If not, a card here, link in the description. Anyway, 20 minutes normally under normal sunlight, so let's give it 2 hours. That cured longer than I intended, basically overnight. So, the only problem I have, I'm thinking of now is how good does that glue work on wood? Because obviously quite good. Yeah. Give me a second. Fortunately, that acrylic glue or polycarbonate glue is not very adhesive to wood. Yeah, it stuck a little bit, but more like gum. So no problem there. And our two pieces are joined together. Yeah, maybe I clean that up and then we glue on the next two pieces. I cleaned the next two parts and I rearranged here stuff a little bit so I have a little bit more space. And also this time I put some lithium grease on the surfaces that should not stick to my part. I'll let that cure now, probably not overnight, but yeah, it's still early morning, or relatively early morning, maybe until afternoon. This time the stuff cured only for about 4 hours, but I guess that should be enough. And almost no stickiness. Well, it doesn't look really nice, does it? But who cares? Yeah. Let me try if the axle still goes through. Yeah, absolutely straight. Perfect. Well, it's not really a work of art or beauty, but yeah, we clean it up afterwards. For now, it's more important to get the bottom part together. The bottom part should be doable in one go. I just don't think I can put any pressure on here anywhere. Oh, we'll see. That cured for 3 hours now, so yeah, I mean, they say in sunlight or with light, it only needs, let me adjust the exposure, it only needs 20 minutes to cure, but I'm indoors here, so yeah, no UV radiation. Okay, that came apart easy enough, and it's not completely cured. But yeah, the axle is still turning. Still turning. That's important. Yeah, but there are some big globs, and yeah. So we will give it a little bit more time, and then we see if everything still fits together. Whoa! Perfect. Just perfect. So, my laboratory water bath, I didn't know, have I cut it and linked it? Anyway, card to the playlist, link in the description, is perfectly able to seesaw on that thing here. The fit of the non-critical dimensions is actually quite atrocious. Yeah, something on that corner. Yeah, it moved 2 millimeters while I was gluing it together. I have no idea why. It's my first time gluing that stuff, so yeah, learning curve. But it's definitely holding together. And the critical dimensions, so especially the main axis, that went very well. Let's not talk about the finish. That's even more atrocious. Yeah, but it's working. So, next steps. Yeah, either putting in the servo and the pin and the push rod, or building the controller. Depends which parts come in first. I believed that I still have an M3 threaded rod here to use as a pin, but I don't. So, yeah, we'll see. Till next time, bye. This is bye, bad, bye.